Okay, so hello and welcome everyone. My name is Ben Zamzo and I'm going to do a walkthrough on the estimating elasticities assignment. So the first thing actually as you're starting this, as you're looking through this, is to take to heart the basic application of the definition of elasticity, which is that we want to find the effect of a change in one variable on another variable. Elasticities are all about responsiveness. And to be able to identify that effect, we have to be clear. We have to be sure that that effect is only coming through one channel. So in particular, if we're interested in the price elasticity of demand, that's the percentage change in quantity given a percentage change in price. We want to find out, how does quantity change when price changes? We already know if it's going to go up or down just by the law of demand. Elasticity tells us how much, right? And to be able to be sure that we're correctly assigning the change to coming through price, we have to make sure that the change in quantity to coming through price, we have to make sure nothing else changes. So it can't be the case that consumer income change or the number of buyers change or any of those things, because those are all demand shifters. And then we're not going to get the change in quantity demanded due to a change in price. We'd be getting this sort of contaminated change coming through lots of other things. Remember, after all, when we're estimating the effects of elasticities, we're estimating elasticities, we're trying to find a change in quantity demanded. So when it comes to price elasticity of demand, we're getting a change in price that causes a change in quantity demanded. If we get a change in demand or a change in supply, something other than price has to have changed. Those are all those other things. Those are all the things we want to not have move if we want to identify a change if we want to identify the price elasticity of demand. We have other elasticities. We have the income elasticity of demand. Then we're interested in, how does a change in income, what percentage change in quantity demanded happens due to a percentage change in income. We have cross price elasticity of demand. That is, how responsive is the quantity of one good to the percentage change in the price of some other good. Anyway, so in the income elasticity, we want to know what's the effect on quantity through income only. Cross price elasticity, we want to know what's the effect on quantity demanded through the other firm's price only. So we're always looking for just that particular pair of variables in this data right here. That's why it's so key when we're asking you which observations you choose and why. You have to choose a combination of price and quantity in part A, where only price and quantity change. So you want months 2 and 5. Why? Well, let's look at month 2. We have price of 218, UA price of 220, income of 3,800 or 38,000, 38K. American Airlines passengers of 62, United Airlines passengers of 63, and then we'll look at month 5. So here we have the change in price. So we want to find what's the change in price from American. So change in price is 218 to 215, 216, right? So price has changed. Good. Well, the other firm's price stayed constant. Income stayed constant. And American Airlines quantity changed. Now, yeah, United Airlines quantity changed, but that's not going to be a shifter that we're going to have to worry about. So so we are interested in only American Airlines price and American Airlines quantity changing. So we do get that with months 2 and 5. Okay, very good. So now we have to show our calculation. Here's how the calculation works. Well, we start with our arc elasticity formula, which is the change, Q2 minus Q1, that's the change. And then to get a percentage change, we want to divide by our starting point. Well, the arc elasticity formula actually takes the average of the two quantities. And so we're dividing the change by the average of the two quantities. Divide that whole thing by the change in price divided by the average price. Okay, so as you're staring at that, that's not what I have here. Why? Well, there's an algebraic manipulation that can be helpful. So here we have a whole bunch of fractions divided by fractions. So remember, dividing by a fraction is the same as multiplying by the reciprocal. So this is the top, this is the bottom, so this divided by this stuff is the same as, well, let's flip it over and make the reciprocal. Cool. And then here's where Numerator comes from denominator, numerator, denominator. And the last thing is this 2. What's going on? Well, I could have canceled the 2 here, couldn't I? Why don't I cancel the 2 there? Let's do it. And so then this is just a boiled down version of the arc elasticity formula that's nicer to work with, especially when I'm trying to write this out in a finite space. So what do you do? Well, let's just evaluate at the quantities. This is Q2, or Q2 is 68. This is where we ended. Q1 was 62, our starting point. Price 1 was 218, and price 2 was 216. It actually turns out if you're using the arc elasticity formula, it doesn't matter which month we'd get the exact same value if we designated, if we were going from month 2 to month 5 as from month 5 to month 2. But we know we know the arrow direction for time. So anyway, so our estimated elasticity is negative 10.01. That's pretty responsive. That's pretty elastic. How do we know? Well, to get an integer for our elasticity, that means that the percentage change in quantity must have been bigger than the percentage change in price, right? If we get a fraction for our estimated elasticity, then the percentage change in price would have been bigger than the percentage change in quantity. That'd be very unresponsive demand. I go through actually all those details in a question and answer video on my YouTube channel, so there's additional intuition about that, but as always, stick with the videos that Price has created for us as the primary videos, because those are the ones that the assignments are all geared towards. Okay, so for the same route, determine the best estimate of income and elasticity. Well, now we only want, so income elasticity. So we want to think of how a percentage change in income leads to a percentage change in quantity. So we want to find 2 months where only income and quantity change. Okay, so month 1 and month 3. Why? Well, price is constant, right? Rival price is constant. Income changes 40 to 42, right? Between month 1 and month 3, income changes. What about quantity? Yeah, quantity changes. And again, yeah, the rivals quantity changes. Who cares? So the big thing is that we're keeping American Airlines price constant, and we're keeping the rivals price constant. Why do I keep saying who cares? Well, our passengers are responding very strongly to the prices of the thing that they're thinking of buying. They're also responding to the rival's price. They're probably not responding very much to the rival's quantity, unless we believe that there are strong network effects. I don't think there's maybe there is. I don't think there's network effects. Let's ignore those. Anyway, so we want month 1 and month 3. So month 1 has the initial income of 40,000, subsequent income is 42. So our denominator is going to be what? 42 minus 40 divided by 41, because the average, right? 41. And then our quantity is going to be, our initial quantity was going to be 65 minus 70 divided by the average. So what? 67.5. Okay, so, and that's essentially what we're doing here, right? But actually, because I did my little trick where I took away the 2's and the averages, so here my 67.5 and my 41, that never shows up here. Maybe it does in your work. Look at what you did. I bet you didn't do it this way, but hopefully we came out with the same number, 1.52. This is pretty income elastic, right? If the income elasticity is positive, we know we have a normal good. If the income elasticity is negative, we know we have an inferior good. Since this is positive and bigger than 1, we know that the percentage change in quantity was bigger than the percentage change in income. So this is pretty responsive. It's normal and a pretty income elastic. That makes sense, right? People's incomes rise, they take more vacations. Okay. Calculate the best estimate of the cross-price elasticity with respect to, for American flights with respect to United flights. Here again, we only want the quantity and the price to change. So let's look at months 2 and 4, because if we have months 2 and 4, well, American Airlines price doesn't change, but the rival's price changes. United Airlines price changes between months 2 and 4. And what about quantity? Yeah, then quantity changes. We need income to stay the same. Yeah, it has. 38,000, 38,000. Very good. And then it's just do this calculation. You get 13.39. And because the cross-price elasticity is positive, we know that these things are substitutes, right? So cross-price elasticity is positive when the percentage change in price of the rival's good and the percentage change in quantity of our good move the same direction. So what this is saying is, as the rival's price decreases, the quantity demanded, the change in quantity demanded for our good decreases, right? Why would that happen? So negative makes a positive. If you're thinking about the sign of our numerator and denominator in our arc elasticity formula? Well, so if the rival's price decreases, then if our quantity decreases, that's substitutes behavior. Why? They're going to fly with the rival instead. The other way that you can get a positive cross price elasticity is as the rival's price increases, our quantity demanded increases. Why? Because the rival's customer comes to us. So that's also substitute behavior. Okay, very good. So either way, if we have a positive cross price elasticity, we know that the goods are substitutes. If you have a negative cross price elasticity, almost following the law of demand, then we know that they're complements, right? Complements are goods used together. So the price falls, you buy less. Price rises, you buy more. And you can think of price falls, you buy less of the system. Price falls, you buy more of the system. Price rises, you buy less of the system. That's complements behavior. But that's not what happened here. That'd be a negative cross price elasticity. Here we have a positive cross price elasticity, so we know we have substitutes. That's why I say CPE is positive. Right, so based on your price elasticity estimate, would American obtain a higher total revenue by increasing its price, higher or lower? No, it'd be lower. Why? Because demand is really responsive, really elastic. If demand is elastic, you raise revenue by lowering price. If demand is inelastic, you raise revenue by increasing price. And I have another video on my YouTube channel. I actually go to great lengths. It's a relatively recent video talking about the relationship between elasticity and revenue. So as always, check with Price's videos first. But if you want, before you run off to Khan Academy or somewhere else, I made my videos. This is one of the things I made my videos in mind with. So, okay, and then we already said substitutes. Cross price elasticity is positive, and then we already identified income elasticity. 1.52 is positive, so we know we have normal good. Income elasticity is positive. The last two. So on this assignment, where do people lose points? People lose points failing to identify a ceteris paribus effect and not choosing months where the only change is isolated to what it is, to the effect that we're trying to identify. That's the first place that people lose points. Where's the other place people lose points? Well, usually part H. And sometimes people lose points on part G. So if consumers have been given more time to adjust to price changes, would you expect the price elasticity of demand to be more inelastic or more elastic? More elastic, more responsive. If you have more time, you can find more substitutes. So the example I like to give for teaching is think about your price elasticity of demand if you're pulling into Las Vegas, New Mexico at midnight and you realize the price has risen substantially since the last time you've been there. Your demand for hotels in Las Vegas, New Mexico, is still probably pretty high on that day, because where else are you going to go? You could drive another hour to Santa Fe, or you could drive back to Trinidad or whatever, but you're pretty much going to pay to stay that night. Now, suppose you're planning a road trip between Pueblo, Colorado, and Albuquerque or Santa Fe, and you know that the prices have risen in Las Vegas, New Mexico. What do? Stop in Trinidad, or keep driving to Santa Fe, or make it to Albuquerque, whatever it is. The more time you have, the easier it is to find ways around. I also like the Las Vegas example, because you start off with the Las Vegas example, and then you think about what if I'm talking about Las Vegas? What if I'm thinking about Las Vegas? What if I'm thinking about Las Vegas, New Mexico? Well, very different. Okay. Cross price elasticity of demand, or consider the price elasticity of demand for the category. If we're thinking about flights on all airlines between Louisville and Chicago, would the price elasticity be more elastic or more inelastic than the elasticity of just American flights? If we're thinking about all flights, this is the entire category. So now, what are the substitutes? Taking a bus, taking a train. Substitutes aren't as good. So demand is going to be more inelastic the broader is the category. I like thinking about beverages. Think about your demand for Coca-Cola. Pretty responsive, right? Because think of like just Coke Classic or whatever. You have lots of substitutes. You have other things made by Coke. You have if we're just looking at colas, you have Pepsi, you have RC Cola. If you grew up in Wisconsin like me, you have Jolly Good Soda, which actually tastes just like Pepsi. Anyway, so you've got lots of substitutes. What about as we go beyond we go to a broader and broader category? What about substitutes for soda? What are your substitutes for soda? Sports drinks, juices, milk, water. Okay, we have fewer substitutes now. And then what if we're thinking about substitutes for beverages? Gels, Food? Jello? Not very good, right? Before too long, as we get to a really broad category, we lack substitutes. So elasticity is greater the more inelastic the category. Anyhow, so I'll go ahead and conclude here. I have other videos on my channel. You can like, subscribe. It'd be of at least some value in the class, but like I said, for the third time, definitely focus on the videos that are in the course, because the assignments are made with those videos in mind. Though you might find something useful here as well, which is just another resource that might be available. Let me know if you have questions, and I'll see you throughout the rest of the course.